Feet slicing is one of the most annoying issues in character animation, so in this tutorial I'm gonna show you how to easily fix animation like this with noticeable amount of feet slicing into something like this, where every step is clear and the slicing issue is gone. So here I'm using an automated approach to avoid any boring and manual work, and everything happens automatically. So at first we're gonna review a little bit of theory to understand how it works under the hood, and then I'm gonna show you how to apply this approach on real examples with some mocap data and generated animations. So here I have a simple walk cycle animation that has a little bit of foot slicing, and I baked animation of the left foot to this cube object, so we can focus only on this specific cube and not being distracted by the rest of the character. So if we go to the graph editor and see the animation curves, we can see that they look essentially like this. So here the object is moving, and here it's supposed to be standing on the ground. But in the animation curve, we can still see some movement. So typically when you want to fix the slicing, what you usually do, you just pick some point, let's say on the ground, copy key from here, paste it, let's say somewhere here, and adjust the rest of the curves to match this position. And do this for the end of the animation. Then delete keys, let's say in the middle, make them linear, and again scale the rest of the curves. So in this way the slicing is fixed, and this can work, let's say, as a desired result. But with this approach you would have to do the same for all translation curves. That might be not only translation Z, but maybe something else, and if there are a lot of steps, it will be a lot of work. So some time ago I came up with a simple algorithm how to automate all this process, and basically to use script to fix the slicing automatically. So let's quickly see how the scripted approach works. First we need to launch the smart layer script. Then we need to create animation layer with our object and set at least one key. The key should be empty without any value. It's just required for the script to understand that we need to apply adjustment to this specific object. Then we need to pick the algorithm fix slicing, and I will also change the layer mode to override, so it would be easier to understand what is actually happening. So after that I need to select layer and run the script. So for now the script didn't work, and let me explain why. So in order to snap object position, first the script needs to understand where to actually snap it, where object is supposed to be moving and where object is supposed to stand still. And the script is using something called speed analysis for it. So if we go to the outliner, we can find a debug speed locator, and if we go to the graph editor, selecting this locator, we can see the speed graph of the object. So when the object is moving, the speed is close to about 100%, and when the object is on the ground, the speed has some lower value. So the goal here is to define where the steps are. So in the algorithm it is done by the threshold value. So we can introduce some threshold. Here by default it's 2%, and value of the speed below the threshold is considered by the script as standing still, and value above the threshold is considered to be moving. So here in this case I would say we need to place the speed threshold somewhere around here, maybe 10%, maybe slightly less. So values here will be considered by the script as standing still, and values here will be considered as movement. And in this part of the timeline the foot will be standing completely still. So this is a very simple logic, but it usually works quite well. You can see by default the speed threshold was 2%, so it was like below the actual speed value, and that's why the script didn't actually work. So let's open the script tab and go to the algorithm options and find the speed threshold value. So let's set it, let's say 10%, and run the script again. And now we can see that the script actually worked and the sliding is fixed. And if you go to the outliner, find the new debug speed object, go to the graph editor, we can see, okay, this was original speed, then we apply 10% speed threshold, and the result speed, marked as green, shows us that here, okay, object will be not moving at all. And that should fix the sliding. And by the way, if we select our object, and let's say compare keyframes on the base animation layer, where we have the sliding, and in the smart layer, where the sliding is fixed, we can clearly see that the animation curve became flat here, and the rest of the animation is adjusted to match this curve. Essentially, it's the same result as we were trying to achieve manually before, but right now it's all done by the script. A flat curve with no sliding. So knowing this information, let's maybe actually try to fix the sliding in our walking animation. I'm gonna delete this foot object and all animation layers. So as usual, we need to select objects, IK controls in this case, add them to the animation layer, set one key with 0 value, then choose algorithm fix sliding, set the speed threshold to 10%, and just run the script. And if we play the animation, the sliding is completely gone. So this was before. We can see some sliding. And this is after we run the script. And if we go to the outliner to find the debug speed objects, we can see all the information about the object speed. So the speed was like this, then we apply threshold, and result speed is like this. And same for the other foot. Original speed, threshold, and result speed. So with this example, everything should be kind of obvious. I think we can switch to more complex animation. So here I have a 300 frames animation take, where the character is walking and turning, and we can see some tiny amount of feet sliding. So this specific animation I generated with Motorica AI. It doesn't have to be specifically generated with any AI, it can be any mockup from any system, for example, like Vicon or anything else, or perhaps any other generator. I was just kind of impressed with Motorica tool, and they kindly agreed to allow me to use their animation in my tutorials under a free non-commercial license, and the link of course will be in the description. So here again we have quite long animation take with some sliding, and let's try to fix it. So first thing we can notice that the character is doing a lot of turns, and as we need to track some position speed to define the steps, first thing I would suggest to track the toes positions instead of actual IK controls, because we can see that the character is often rotates around these points. For example, like here, some rotation is happening, and while the IK is moving, the toes actually stay in the same position. So we would need to switch space from IK controls to some, let's say, extra locator, some extra pivot point that would represent its movement around this specific pivot. So it sounds kind of complex, but it's actually super easy to do. I would just create locator. You can do it with free scripts, you can do it with smart layer. So okay, we created simple locator. After that I will select IK control, this locator, and switch space to selection. So animation is not changed, but right now this locator, it will control the foot movement. And I need to do it for another foot as well. Again, just create locator, switch space of the foot to this locator. I can move the smart layer script somewhere here, and animation looks the same, but the foot movement is baked to these locators. And we can use it to actually fix sliding inside this animation. So as usual, I would need to select required objects. In this case, it will be our extra locators. Add them to the animation layer, set one key, then run the script in the fix sliding mode. Additionally, I would say we don't need to snap rotation, we can work only with position. And maybe we can change the result layer to the override. So let's try to run the script and see if it will work. So apparently the sliding threshold should be a little bit higher. So we can go to the debug speed and see in the graph editor what is going on. We can see that original speed has sliding around maybe 5%, maybe 6%. Okay, this is for the left foot, and for the right foot, again, it is 5-6% of speed. So let's change the threshold in the algorithm options to 6% and run the script again. And we can see that the sliding is magically gone. We can see clear steps. So again, this was before. A little bit of sliding on every step. And this is after we run the script. Clear steps with no sliding by position. So if you want, you can apply an additional animation layer with snapping the rotation, and you can also play with the layer opacity to see the results before and after. You can go to the graph editor and see the result keys. So this was original keys. You can see some movement when the foot is supposed to stand on the ground, and in the smart layer we can see a completely flat curve. Essentially, we're trying to achieve this behavior. If you don't like some keys, you can adjust them manually. If there is any jiggling or weird behavior, you can just smooth these keys in the curve filters tab. Just apply a little bit of smoothing if you want. But I think everything should be kind of okay. So in this example, the main point is that you don't necessarily need to track the IK controls. You can switch space to some more appropriate pivot point. If there is some rotation around the toes position, it makes more sense to track actual toes position, not the IK control, which is rotated around this pivot point. And after you're satisfied with the adjustment, again, you can just bake these controls and delete locators. You can bake it on base animation layer or bake it to another animation layer, delete locators, delete these animation layers, and call it fix sliding. And you can easily see the results like before and after. And going back to this original example, where the character is jumping around and there is some sliding, I think similar to the previous example, we would like to track the toes position, because again the character is jumping and standing on the toes. So same as before, I will create extra locator and switch space of the foot to this extra locator. And do the same for the other foot. Again, select the toes control, create locator, select the I key, the locator, and switch space to selection. If you don't know about the space switching, I have a dedicated lecture about it. I will put a link in the description. So again, animation is not changed. It looks the same, but right now these locators, they control the feet behavior. And after that, I need to select these locators, add them to the animation layer, set one key, go to the smart layer tab, choose the algorithm fix sliding, in the bake options, we can choose to snap only translation, but not rotation. Maybe choose the layer to be override. And the speed threshold, we don't know yet what value would work the best. So for now we can just run the script with 2%, see if it works. Okay, it didn't work. So let's go to the debug speed and see what is happening in the graph editor. So here in the graph editor we can see, I would say, quite noticeable amount of sliding, somewhere around 10%, sometimes even 12%. Here it jumps even higher. So let's see the other foot. For the other foot the situation is kind of similar. So I would say in situations like this, when the speed curve is not smooth, it is constantly going up and down, it might be beneficial to smooth this curve before applying the tool. So in the script there is an option to smooth speed curve. So instead of like going like this, we can get some kind of average value from this curve. And this average value can actually work better in case when we have such noise in the mocap data. So let's maybe try to apply the script without any smoothing, but with speed threshold around 12% and see if it works. So yeah, it worked, but here we can see that some weird stuff is going on. That we have some jiggling, some teleportations, and if we go to the debug speed of the left foot of the frame 66, again we can see that we have some intersection with our threshold speed. So ideally we would like to smooth this curve to get rid of these false steps. So I'm gonna introduce a little bit of smoothing. Let's say smooth over 2 frame interval and try to run the script again and see if it works. And right now there are no issues to fix sliding in this animation. So let's see how this smoothing worked. Again, select debug object for the left foot, and in the debug speed we can see, okay, this was original speed and this is smooth speed, marked as blue curve. And this smooth speed allowed us to get rid of these false positive steps and do the adjustment better. So with the smoothing you don't actually have to use it very often. It's mostly for the cases when the mocap data has some noise. And I think this is all for this take. So we basically switch space to some extra pivot point, add it to the animation layer, run the script in the fixed sliding mode with speed threshold about 12% and with a little bit of smoothing. After the adjustment is done, we can select our eye controls, bake them to the original animation layer or bake them to the new animation layer, delete all extra locators, delete all these animation layers, call this layer fix sliding, and see the results before and after. So this was before, some sliding, and after, again, the sliding is fixed. And the last tip I would like to share is how to handle legs overextension. So for example here, when we fix the sliding on this feet, we got legs overextension because the length of the step changed and steps became longer. So in original animation we don't have any problems with the legs overextension, but when we fix the sliding, we can see that now there is not enough length of the leg, and we can see some knee pop issue. So in order to fix this, we can use pelvis correction. You can find about the pelvis correction in the first lecture about the smart layer. So right now I will not spend much time explaining the basics, but what you should know is that pelvis correction works with a fixed sliding algorithm. So if you select the pelvis object, add it to the animation layer, set one key, and then go to the pelvis correction, enable pelvis correction and select appropriate config for your character. It should procedurally move the pelvis according to the change in the step length. So let's run the script again, but with pelvis correction enabled, and see if it helps. So the script worked, the sliding is fixed, and we don't have any pop issue anymore. Because again, the pelvis correction, it moved pelvis down to keep the same length of the leg. And we have separate keys for the pelvis on this additional animation layer. Again, if you're interested to know more about how the pelvis correction works, I will leave a link in the description. This will be all for today. I apologize I disappeared for so long from my channel, but I hope you understand the Kronos release was a little bit tough time for me, but now I'm back. So Merry Christmas, Happy New Year, and hope to see you again on the channel.